talking about a very important subject, that is option Greeks, in this video. Option premium changes with change in the factors that determine the option pricing. So that is the factors such as strike price, volatility, term to maturity, etc. The sensitivity of option premium to each of these factors is known as option Greeks. And these Greeks are delta, gamma, theta, vega and rho. We will talk about each of them in detail. Let's start with delta. The delta measures how an option value changes with respect to the change in the underlying. Means the delta of an option help us answer that by how many points will an option premium change for every 1 point change in the underlying. So I can say that delta captures the effect of the directional movement of the market or the underlying on the option premium. Another important point to note is the delta value ranges from 0 to 1 in case of call options and -1 to 0 in case of put option. Why? Why is delta negative for a put option and positive for a call option? We have discussed this earlier that with 1 unit increase in the spot price, call premium increase and put premium decrease. So if call premium increases with spot price increase, so delta of a call option has to be a positive number and vice versa in the case of puts. Now let's assume a call option has a delta of 0.3. What does this mean? We know that delta measures the rate of change of premium for every unit change in the underlying. So a delta of 0.3 indicates that for every 1 point change in the underlying, the premium is likely to be changing by 0.3 units. Consider Nifty at morning 10:55 AM is trading at 10,288 and we are considering an option strike price of 10,250 call option. The premium at which it is trading is say rupees 133 and the delta of this particular option strike price is 0.55. Now say Nifty at 3:15 PM in the afternoon is expected to reach at 10,310. So what will be the option premium value in the afternoon at 3:15? It's easy to calculate. We know that the delta of the option is 0.55 and we are expecting the underlying to change by 22 points, that is 10,310 minus 10,288, which gives us a difference of 22 points. Hence, the premium is supposed to increase by 22 points into 0.55, that is the delta, which is total of 12.1 rupees. Therefore, the new option premium is expected to trade around 145.1, which is basically 133 the earlier premium plus 12.1 the change in the premium. Let us pick another case where if one anticipates a drop in Nifty, what will happen to the premium? Let's figure out that Nifty at 10:55 in the morning is trading at 10,288 and the option strike price is 10,250 for a call option and same the premium is trading at 133. Delta of the option is 0.55. Now in this case, Nifty at 3:15 PM in the afternoon is expected to reach at 10,200. What will be the premium value at 3:15 PM? We are expecting Nifty to decline by 88 points, that is 10,200 minus 10,288. Hence, the change in the premium will be 88 into 0.55, which is 48.4. Therefore, the premium is expected to trade around 133 minus 48.4, that is 84.6, which is going to be the new premium value. As we can see from the above two examples which we just discussed, the delta helps us evaluate the premium value based on the directional move in the underlying. And this is extremely useful information to have while we are trading options. For example, we assume that we expect a massive 100-point move up on Nifty, and based on this expectation, we decide to buy an option. There are two call options, and we need to decide which one to buy. The first call option has a delta of 0.05 and the second call option has a delta of 0.2. So obviously we should choose the second call option where the delta is higher, that is 0.2. So if Nifty moves around 100 points, premium will move around 20 points vis-a-vis 5 points in the case of first option. Now that we know that the significance of delta, and also we've understood how one can use delta to evaluate the expected change in the premium, let's discuss the quick pointers. Call options has a positive delta. Put options will always have a negative delta. Out of the money options have a delta value between 0 and 0.5. At the money options have a delta of 0.5, and in the money options has a delta between 0.5 and 1. Let's have a look at the table to understand and tabulate it. If the option type is deep in the money, a call option delta value will be approximately between 0.8 to 1, and for the put option it would be negative minus 0.8 to 1. If the option is slightly in the money, then the call option delta is between 0.6 to 1 normally, and for put option it is minus 0.6 to minus 1. If we are considering an at the money option, the call option delta normally varies between 0.45 to 0.55, whereas in case of put option it is negative 0.45 to minus 0.55. In case of slightly out of the money option, we can see that delta for a call options normally ranges between 0.45 to 0.3, whereas in the case of put option it will be minus 0.45 to 0.3. And if the option type is deep out of the money option, then the delta value will be 0.3 to 0 in case of call options and minus 0.3 to minus 0 in case of put options. With this, we come to the end of this video explaining delta of an option. In the next video, we would be talking about gamma of options. Thank you.